Hello, everyone. Welcome to our binary focused episode for the podcast this week. As always, before we jump into topics, we'll cover the Spot the Vuln solution from yesterday and today's episode. So, Z, I'll let you take that away because these are your challenges. So, go ahead.
Yeah, and this week was didn't need to figure out how exactly to exploit this, although some people did make a couple guesses at it. It is a little bit compiler dependent. But the actual issue is line 12, we do results, and then to figure out the index of the results, and that is a typo. If you're looking at this on line 6, I have result, and line 12 is results with an S. That's just a typo. Those two should be the same variable. Um, anyway, to
Didn't even
calculate.
compile it.
Yeah, well, so I did compile this the first time we used this on one of your streams, and then I retyped it all out to use it here, and that's where I made that mistake. So I didn't compile it this time.
Yeah.
But I actually did compile it because I played around with trying to exploit it the first time I made it. Anyway, the issue when it's calculating that index on line 12, the idea is it's just calculating like how many even and odd numbers. If you give a negative number, doing like a negative number mod 2 or mod any value will result in, whatever the mod would be, but it'll be a negative value rather than always being, a positive value. So like a, negative whatever mod 2, you can end up getting an index of negative -1, which gives you that out of bounds increment. So you can increment whatever is just before that in memory, which depending on the compiler, could be that line pointer. So you can end up getting a controlling where that writes to and then where the value that reads into the line goes to. So
Yeah.
that's the
So,
basic idea with it. You might be able to exploit that way, compiler dependent though.
that's the interesting aspect of the challenge is I'm not sure if you would get control over line or if you would get control over end. Um, but like you said, like it's hard to really say. It'll depend. Um, if there were no other variables there, you could even get control of like the stack pointer or something. Actually, no, because you're gonna hit other padding. But I mean, anyway, it's an interesting challenge when you think about how you could try to exploit it. Um,
Yeah, I think I
and yeah,
did
I
get
really like this
line
challenge when you did it
when I
before.
used GCC. I think I might have been testing with TCC. I don't remember for sure, but I mean, there's a chance you can get line. It's dependent there. If you want to make sure, you'd have to use a structure or something that guarantee the order, because current compilers will reorder um your declarations on the stack into its own little order.
Yeah. And Belika points out you could also cause an infinite loop by messing with the start and end. Yeah, you could do that as well.
Yeah, I mean
Um,
that's getting a little bit more on. I mean, denial of service is a fair thing to point out too. So yeah.
yeah. But primary issue there is just using assigned value for the iterator and for like the values you use for in the loop. So um, yeah, like I said though, cool when you think about how to exploit it. So along the same lines of having signedness issues, our first topic actually touches on that. This is a post from Mozilla on a heap overflow and the parsing of MAR package files, which is used for updating for Firefox, but also Thunderbird. Um, this is a bit of a root cause analysis and contains a good introduction to two's complement and how it can lead to problems. Because, like I said, ultimately this is a signedness issue on the name length when inserting MAR file entries into a list. One of the things it does is it'll copy the provided name parameter into the item name, and it'll use the name length plus 1 to do that. The problem is that name length is taken as a signed integer, and if that name length is the max value of a 32-bit int, and you try to add to a 32-bit integer, it'll overflow to a negative value, right? So when that 32-bit signed integer is passed to memcopy, it gets sign extended to a 64-bit value, which memcopy then reads as unsigned, which is super large, and that's where you have the overflow coming into play. So the fix there was dead simple. Just simply change the parameter so that the name length was unsigned instead of signed. That way, when 1 is added, it just wraps back to 0, and 0 bytes end up being copied. What I think is nice in this post is how like deep it goes into two's complement and how binary math works. This might be a good thing to link for people who are maybe having trouble wrapping their head around that, or what the potential issues are with like C math, as they call it. Um, I
Yeah,
just
because
think like
it's
the amount of depth they went into there could be helpful to like newer people who might not be familiar with the concept.
yeah, when I saw the title in the first bit, like I was expecting, okay, it's going to be that sort of integer sign type issue, and then I saw how much background they went into here, and yeah, for a lot of people, this will be fairly familiar, but it's well done in terms of explaining why this is an issue, and it's not something that is really intuitive until you think about it. Like even two's complement, like until you think about and really recognize the value in even doing that, it seems kind of like a foreign idea in general too. Like, why are we storing negative numbers this way? So I thought it was a good post for that reason. Vulnerability isn't too interesting. I mean, it's a relatively common vulnerability still after all these years. And I do appreciate their takeaways. First one, don't use C.
Okay, so maybe we'll have a bit of a disagreement here because I'm not really a fan of the way they rip on C here and say don't use C. Um, I kind of get what they're trying to push, like using safer languages so that you don't even have to worry about this stuff. Okay, in a way that makes sense, but I think trying to blame C for having this issue like, yes, C can be dangerous and implicit conversions can bite you. Because part of the problem there too is that memcopy will internally implicitly convert any value you pass to it to unsigned. But this isn't really C's fault. Um, because you should never really be using a signed value for a length like this. So, yes, I kind of get their angle where if you can use a safer language and it makes sense for what you're building, then you should probably do it. But at the same time, I think it's unfair to blame C for like making a mistake with how you typed your variable.
I think it's
So
still actually pretty fair to blame C on this, just because of, I mean, it's not just the type, but the fact that C kind of allows and more or less encourages that sort of very dynamic typing. And it is a more general issue. It's not, well, this particular issue we may only see really in C native languages. You have the similar, just the dynamic nature of the typing system allowing you to just, or doing these implicit conversions. It also causes problems in other languages. Like PHP is famous for those implicit conversions that it does and just like causes so many types of bugs. You also have a bit of it with JavaScript, just a lot when it comes to scripting languages, but PHP and JavaScript are kind of the two standouts there. I think it's still fair to blame the language for its design that encourages certain things, even if ultimately it is still the developer making the mistake.
yeah, I mean, I don't know. I can kind of see that perspective, but when you're talking about something that's performance critical and something, um, well,
I'm
I don't
not
know
saying
if
you
you would
can't
consider like
choose.
an update system like something that would absolutely have to use C, but yeah, I don't know. It rubbed me a little bit the wrong way. They were like just don't use C ever. It's maybe that's personally just because I like writing C. I do like C as a language. I don't think it's the best or perfect. It does obviously have issues, like you were pointing out with the implicit conversions, but yeah, I mean, ultimately, even though C might not have a great design when it comes to those conversions, this was all caused because they used assigned length, which is like never a good idea, really, unless you have an explicit need for that. Like there is some paths in C that I've seen before where it does error handling and it uses that signed size type, and that's kind of a good area to look for problems because that can be tricky to handle. But um, generally, most of the time, you're going to be wanting to use unsigned. And if you're using signed, you have to explicitly make sure you check um,
I mean,
properly
I
before
don't
just passing that to
disagree
memcopy.
with you on that point. Like, obviously, there are ways to have avoided this in general, but the language design encourages some of these issues too. I mean, pretty much every buffer overflow in the past, 20 years, 20 plus years, and go back to, some developer making a mistake because they didn't understand the nuances of the language itself. or didn't understand the nuances of how things were getting passed along. Like, language plays a part in that, even though the developer's ultimately responsible.
Yeah, and I mean, on that note, something that's probably good to bring up here is you've always encouraged people who want to learn like C and learn systems programming to learn some of the stuff under the hood, like how a little bit about assembly, like how registers work and how like binary math works at the low level. And this is kind of a good example of why it's a good idea to do that, even if you're not going to be like most people, 99.9% of people are not going to be doing any handwriting of assembly. Um, they're going to be using compilers or whatever. Most people aren't even going to need to read assembly unless you're like reversing or trying to track down a really tricky bug. But like just having the knowledge of how stuff works under the hood can benefit you in situations like this to find those types of bugs and to understand the impact of them. So I just thought I'd call that out because that's one thing you've encouraged for a while. And I think maybe it's not a super common recommendation. People just think, I'm never going to write assembly, screw it, I don't care. But there's reasons for like good reasons for learning how things work at that level. So
Yeah, although you have to be careful with that because, like, writing assembly in a programming sense is different from the types of assembly that you deal with in like phone research and exploit development. You don't really run things through like the assembler, which gives a ton of extra features that actual assembly, or at least the machine code, just doesn't have. But I think we're kind of starting to jump a little bit off topic there.
yeah, it was just something quick I wanted to bring up. But yeah, with that said, we can move into our Chrome exploits. So we have two vulnerabilities this week in Chrome: a type confusion and a use after free. We'll start off with the type confusion, which is in the JIT compiler of Chrome. This is a technical analysis from Manu Mo, posted on GitHub Security Lab, who we've covered before. This is his own perspective and thoughts on how this could be exploited, because this vulnerability was found to be exploited in the wild. So this isn't necessarily the way it was exploited in the wild. This is just like his take on it. He wants to state that up front, so I thought I'd state that too. But yeah, Z, I'll let you take this one away.
Yeah, and I will also mention that there is a Project Zero post, like a root cause analysis on this same bug, from the same author too, actually. Although I'm mostly going to be basing what I know off of the Security Lab post here. But this one is, well, like a lot of the deeper Chrome issues, it's going to be a little bit of a pain to nicely and distinctly summarize it. But one of the core concepts that you do need to understand to get this bug is the idea of a map. And a map in this context, inside of V8, is a kind of hidden class that represents the memory layout of like a JavaScript object. So it's not like your hash map or any other places that you've heard of maps. So when you hear me talk about maps, I'm talking about this sort of memory layout or thing that represents the memory layout. And it's used, they'll be shared across multiple objects. So if two objects have the same memory layout, they'll both have the same map. And it's used during the optimization process. This is ultimately a bug in the optimization process. So as it's optimizing, that's how it knows, like, where's this property of the object? Where's that located in memory? It's going to look the map. So one of the key things that can happen with a map is if you change an object and you like add a new property, then the map will have a little transition added to it, and that object will take on a new map, and that transition just tells you, like, here's this old map that other objects may still be using. If you need to get to this other type of object that you just add the property for, you can follow this transition, and here's this other map that's, the right shape and size, whatever, however you want to describe it. It'll follow that along. And when a map has a transition in it, it is considered an unstable map. So when it comes to optimizing some code that accesses a property, it's going to add a check, making sure nobody reassigns the map if nobody reassigns the object itself or the property itself. That is one nuance here. I'm going to switch back and forth between using the term property and variable at a couple points, or just object. So a global property, this is specifically vulnerability in a global property. That is like all of the global variables in JavaScript are properties of the global object. So I'm kind of using them interchangeably. I'm sure there is some deeper nuance between this I should know, but not doing Chrome exploitation, it's not something I am intimately familiar with. But anyway, so when you have the property access in optimizing that, it's going to add a check, making sure like nobody goes and just reassigns the value of that variable out. Obviously, then the optimization might be wrong. Not a good idea. If the map is stable at the time of optimizing it, then it's going to add a check just saying like this map needs to stay stable. The other thing, if it, or actually, I believe regardless, it'll also just check the map and make sure that whatever map is being assigned in this optimized code, it'll check that map and make sure it has like the right properties at least. So make sure the map hasn't changed, basically. If it can't just rely on it staying stable. So as I've hinted at, the issue is with Turbofan writing the optimization code for storing into a global property with the k constant type. Objects, I believe, will start out as k constant type, and then once you mutate them, they become k mutable or mutatable. I don't recall which one it was. It changes there. Doesn't really matter. Just k constant type happens to be the one with the issue. And what ends up happening is if it's optimized while the map is unstable, then as I mentioned, depends on stable map won't be added to it. So it's not going to depend on that. It's just going to have that check that looks for the two, or that looks for the map to basically be the same at the time of assignment. And that ends up creating this kind of cool type confusion. And it depends on kind of two functions being optimized. One's going to be optimized to make an assignment to that global property. The other one is going to be reading or accessing one of those properties. Having those optimized at different times on different maps, you can kind of create this type confusion where first optimize on like a store on that global property while it's unstable, add some new property to it that's going to create a new map, and optimize on accessing that one. So you have these two pieces of optimized code. One stores a value, one is just accessing a value. That access, it's going to expect that whatever object it's looking at has that has that new property in it, because you're optimizing on the access, but also like that's the map it had at the time. So that's what it's going to expect. But that first optimized the store function, when that one gets optimized, that one is expecting the older map, or the first, that unstable map. And nothing tells it that the map is basically changed. So you're able to go ahead and go back and assign a new value to that same variable that the second function was optimized on. Assign a new value that takes it back to its old type. Again, it's checking for that old map to be the map being assigned there. So you can end up replacing it with that older version, or just some that has the older map. You replace that, and then when you go back to use that optimized load or access, it's still going to expect it to have the new map. And that's where you get the type confusion where basically the type is changed out on it, so it thinks that it has a property that it doesn't. And I mean, that's, I guess, the gist of that one. I would encourage you to give this a read. It did take me a little while to get through this post. I think I probably sat on it for like an hour or two. As somebody not really familiar with the browser exploitation, but it's, I think, a really well done post for covering the actual bug.
Yeah. So for exploiting that, they basically cause the confusion between different array types, which is a somewhat common trick in browser exploitation. So they confuse like an array of integers, which an integer in JavaScript is 4 bytes, and an array of doubles, which is 8 bytes. And then by causing that misalignment, you can hit some internal data structures in order to derive a read-write primitive. Now there is a bit more to it than that, because you're working in the optimizer, not in the JS core. But overall, the strategy is fairly standard there. They then also use an existing technique to get around no execute protections. Now, you can commonly get around no execute by using WebASM, but they actually found a different technique by Brendan Triska, which was kind of funny. I got a bit of a laugh out of this. He wanted to just find a way that you could bypass like no execute without using WebAssembly, and basically all you had to do was smash a heap field. Like the heap has this global object for settings and whatnot or configuration, and it has this field called write protect code memory. So if you just smash that to 0 using your read write primitive, it'll make it so that all new memory chunks that get allocated are allocated as read write execute. So it's kind of it was more simplistic than I expected it to be, to be
Well,
honest.
that's a
But
nice flag to have.
yeah, so it was kind of a funny bypass, I thought, but yeah, I won't go too much into detail on that because that's out of scope of the post. But um, yeah, like overall, the impact of this is it gives you code execution in the renderer of Chrome, which, when chained with a renderer escape, that can allow a full sandbox to RCE, sandbox escape to RCE. Which actually we do have a renderer escape as our next topic, so I guess we'll jump into that quickly. Um, it's the end just said TLDR compiler makes assumptions based on runtime checks, but one optimization forgot to add the runtime check. Yeah. It's pretty funny because I tentatively follow browser exploitation. I don't do much of it. I haven't done anything in Chrome. I've only done exploitation in WebKit, but uh, seems like pretty much all the new issues that have come out in the last year or two have been optimization issues or JIT bugs or both. Um, I haven't really seen one in JS Core in forever, which kind of sucks because those are the ones that are like easier for me to exploit and can be taken advantage of on systems that don't have JIT. But seems those are kind of dead at this point, fortunately. But yeah, so we'll move into our next UAF. This one was in the Java code for Android. It wasn't in the native browser code. The vulnerability is in the code responsible for getting credit card information for autofilling. Uh, in that process, it'll invoke this function that checks if the verifying platform authenticator is available, which is handled by this internal authenticator class. And the method in that class responsible for that stores a reference to the internal authenticator Android and a callback as a Java Lambda. The problem is, if that authenticator somehow gets destroyed, that Lambda will still hold the dangling reference to that object. And the lifetime of that authenticator is attached to a render frame host. So when that dies by doing something like destroying an iframe, so does the reference, and that's where the UAF happens because the Lambda still has the dangling pointer. Not the first time we've seen a bug like this. We've covered a few issues in the past, actually, that had a very similar issue with UAFs on objects attached to render frame hosts.
I
The
feel like
last two, what was that?
I was going to say I feel like we've all seen something similar with some audio stuff.
Yeah,
Um, and the audio processing being used to extend the lifetime.
yeah. So the last two episodes we talked about render frame host. If you want to go back to that, was when we were still doing numbered episodes back in episode 67 and 69. In fact, episode 69's topic was from the same researcher that this is from, uh, posted back in March of this year. And it was very similar in nature, where that one was in the payment app service bridge, and it also involved the internal authenticator Android class. So yeah, in this post, there's not really many exploitation details, but I imagine it would be pretty similar to those other issues I've already mentioned. So, if you really want those exploit details, you can go back and refer to those topics, especially episode 69's topic, and you could get a pretty good idea of how to take advantage of that. Um, the report outright mentions that this can be used to gain sandbox escape from compromised renderer on Android, so we know it's totally exploitable. Um, and I think this issue could be chained with the previous one as well to attack Android. I'm not 100% certain on that. I don't know for sure if the last bug would be present on Android, but I can't
Well,
imagine why it wouldn't be. So you could probably chain these two together to get a Chrome RCE sandbox
maybe,
escape.
but this one requires that credit card details actually be saved in the system. So I feel like that might be a little bit of an ask. That's going to limit like who can kind of be hit by this one. Because this one did require, I don't recall if it was mentioned in this post or another one, or if when I was digging into it, yeah, might have been elsewhere.
Yeah, I
But
was just taking a quick look to see. I don't see it mentioned anywhere in this post, so if it was mentioned, it might have been maybe in the. No, okay, that's a different reference. But I mean, that would kind of make sense given the area that this vulnerability is located in. So that's a fair stipulation to point out. So I guess what I would say is it could be taken advantage of against Android, but it's probably not the most ideal uh, sandbox escape. There's probably some other ones that would be more ideal. In fact, the last post that we covered talked about chaining it with a different bug, but it wasn't this one. They talked about chaining it with IndexedDB API UAF. So yeah,
yeah,
bottom line is though it could be chained. It's just not ideal.
I'm actually kind of wondering where I did see that about the credit card information. Given the functionality, like it does make sense, but I'm sure I saw it mentioned somewhere. Maybe it was actually on the Chromium issue itself.
That's what I was thinking. I was just going to take a quick
Yes,
look there.
this issue requires a user have already saved a credit card in their Google account. Which I mean, there are definitely a lot of people who have done that, but it is a little bit limiting that.
Yeah, it's a prerequisite to exploit it. So yeah, fair to point out. Um, but yeah, that's the vulnerabilities and exploits that we have for this week. Finally, we'll move into something that just happened today, which is Phrack released issue 70. First time in like 5 years that a Phrack issue has been dropped, so pretty notable. Um, Mostly, the issue consists of things that were already in the paper feed. For example, like attacking JavaScript engines. That's a pretty old paper, but or a pretty old article, but it was added to this issue.
Yeah, because
Um,
that one was like what 2016, wasn't it?
Yeah, I believe so. Yeah.
Yeah, that's so a lot of these definitely have already been seen. In fact, we've covered a couple of them on the podcast. Like I believe we covered the two hypervisor bugs escaping from FreeBSD Beehive.
Yep. So
Uh,
it seems the whole idea with dropping this issue is to consolidate everything from their paper feed and move forward. Moving forward, it seems like they're not going to be using the paper feed because that link doesn't work anymore. Um,
yeah,
which
well, the
personally I
link,
don't like, but
yeah, it's still there up at top, but it just goes to the Phrack homepage, which is to their CFP for issue 71. So yeah, unfortunately, because I did kind of like the paper feed. It was, you know, especially if they're not going to be doing regular updates, that was a nice compromise to still have the Phrack posts without actually needing to have enough to do a full issue of them.
yeah.
So a little bit
So
disappointing. If
yeah,
that's the
so I
case, they don't mention it. Sorry, I keep cutting you off.
no worries. Yeah, so I don't know if the plan going forward is to maybe increase the frequency of their releases because if their releases are only going to happen every couple of years, um, then it's really unfortunate that like the paper feed seems to be disappearing because I'm not a fan of the idea of like holding back the articles for such long periods of time just to like group them together. Um, Personally, like you, I like the paper feed. Um, though you were saying also that is like fairly new. It hasn't been around for super long either.
Well,
Um,
it's not super long in comparison to the history of Phrack, at least.
yeah. Because you said it came out after issue 69, like
I believe
so
so,
sometime within the
yeah.
last couple of years. Um, but yeah, I mean a little unfortunate there. Um, Another thing I wanted to call out from this is Live Overflow had an article that was added to issue 70. Um, I'd recommend giving it a like read. It's pretty light. It's not a super long read, so if you have some time, I'd recommend checking it out. It just talks about like content creation and like YouTubers doing infosec and streamers and stuff. Um, I saw it making the rounds on social media. There were some people calling it out, like asking why something like this was added to Phrack, where Phrack usually has the more technical stuff. And like Live Overflow even pointed out, they've had a history of having articles that have talked about like international scenes and stuff. So this isn't really out of place.
Yeah, I mean, I think
And
actually 69 had one that was, yeah, international scenes.
yeah,
But yeah, no, they usually have a mix. Like they always have technical content. That is what Frack's known for. But they haven't, like, it's not unheard of to have some softer topics in there either. Also,
yeah. So like I said, pretty quick read. There's some interesting stuff in there for sure. So if you have some time, check it out. But yeah, for the most part, a lot of the articles in this issue uh, are like pre-existing articles that were posted on the paper feed. But now they're all consolidated there. So if you want to take a look, check it out. Hopefully, like I said, we see like more Phrack, like more frequency with the Phrack issues, if they are going to be moving away from the paper feed. But yeah, that's pretty much everything we had for today. Thank you to everyone who tuned in. You can catch the VOD on Twitch or on YouTube at 8 p.m. Eastern on Wednesday. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to get involved with the community or get alerts when any content goes out or live streams are up, join our Discord and follow us on Twitter. Links for those are below the video, and I'll post a link to our Discord and chat. We'll be back next Monday at 3 p.m. Eastern, 12 p.m. Pacific for our bounty half of the podcast, and next Tuesday at 7 p.m. Eastern, 4 p.m. Pacific for more binary stuff. And we'll see everyone next week.